So this is where kind of it all starts. This is the torque converter. It's connected to the engine. When the engine spins, this whole thing spins with it. It's bolted to it. In a manual transmission, the mechanism for connecting the transmission to the engine is mechanical, the clutch. There's a mechanical connection between the clutch and the engine that ultimately turns the wheels. But in an automatic, it is not mechanical. It's fluid. This is actually called a fluid coupling, meaning that it's filled with fluid. As this spins with the engine, it turns a turbine via fluid, and then that fluid force gets transferred to the wheels. That's the reason why you can stop at a stoplight and the engine doesn't stall, because it'll just keep turning the fluid, and that doesn't put any strain on the engine to cause it to stall. The next major part to the automatic transmission that almost every automatic transmission has is a planetary gear set. And these three gears together are a planetary gear set. This one is the ring gear, because it's the gear that's the outer ring of the whole set. This one is the sun gear. They call it a planetary gear set because it has a center gear, and then it has little planet gears that go around it. And that's what this is. This is the planet. This is the planet carrier, and these are the planet gears. So altogether, this makes the planetary gear set. So sun goes into the planetary carrier, and you can see that when I turn, see how the planets rotate around the sun, right? You get it? Alright, so now the planet carrier with the sun goes into the ring gear. And this whole assembly, this is the planetary gear set right here. This is how the automatic transmission gets its different gear ratios. In a manual transmission, there are separate gears for 1, 2, 3. Each gear has its own physical gear. But in an automatic, that's not how it works. They use these planetary gear sets to make multiple gears. The way it does this is it will hold one of the components steady, either the sun, planet carrier, or the ring. It'll hold one of them still and allow the other to rotate around it, and that will change the gear ratio depending on which one you hold still. Here's an example of how it does this. If I hold the planet carrier, this guy, still, and allow the ring gear to turn, say my input is the ring gear and my output is the sun gear. Well, if you look, if I turn it to the left, well, my left, do you see how the sun goes right? Opposite direction. So this would be something like a reverse, right? The engine is turning one way all the time. So the transmission will then hold the planet carrier still and allow the power to be transferred to the ring gear, which then will go through the sun gear to the wheels. See how it's turning the opposite direction? Depending on which one you hold still changes the gear ratio. If I hold the sun still, you know, it's all different. What the transmission will do is it will use maybe 2 or 3 of these sort of daisy chained together to get different gear ratios. But this is pretty much how it works. So basically, it just uses these planetary gear sets, and the way it gets different gear ratios is to hold one component steady and rotate the other components around that steady component. So the next question is, how does the transmission physically hold these gears still, and what regulates that? And that's next. So here's an example of what I was talking about. This center shaft ultimately connects to the ring gear of the previous gear that I showed you. When the transmission is in one gear, this is spinning. Maybe even the whole thing is spinning. Now, if the transmission wants to hold this component still, one way to do it is with a band. This is a band. It'll go around here, and when the transmission wants to hold it still, it'll squeeze it and then hold this drum still. And that's one way of holding different gears still, is by using drums and bands. The other way is by using clutch discs and steels. And these are the clutches and the steels. And the way these work, steels have teeth on the outside. And these teeth, in this particular case, are splined to the actual case itself. So these steels never rotate, they just sort of float in there. Between each steel is a clutch disc, and as you can see, they have teeth on the inside, but not on the outside. The way these work is they'll be sitting, it'll basically be somewhat like this inside the transmission, where the clutch disc is between the steels. These clutch discs are splined to some gear, one of the gears inside the transmission. They are actually splined to this gear. They go on these gear teeth. The clutch discs sit. The rest position, these clutch discs are just floating. They're floating in the fluid. The gear is allowed to spin. If the gear wants to spin, it'll spin because there's nothing holding these clutch discs still. Now, when the transmission wants to hold that gear steady, there will be a piston that squeezes all these clutch discs together. And when it squeezes that, remember, these steels don't spin, so it'll lock the clutch discs to the steels, which in turn will stop them from spinning. And since the clutch discs are splined to the gear will, when it wants it to spin again, it just releases the pressure and allows the gear to spin. So this is how the train actually controls when the shifting occurs and what does it. This is pretty much the brain of the transmission. It's called the valve body. There's a series of fluid passages that direct different pressures of fluid to different areas. And if I lift this, you can see all the fluid passages in here. But it's filled with valves that move and control where different fluid goes at different times and different passages. And the whole thing is run hydraulically through this huge hydraulic circuit. Here's an example of one of the valves. This is the throttle valve, and you can see you can push it in and it pushes back with a spring. And this particular valve is controlled by your throttle cable, and it changes pressure in the valve body. So say you're cruising in 4th gear and you need to accelerate very fast. You're in a situation when you need a lot of power. So you floor the linkage is sent through here, which pushes down on this valve, which will open up different passages to allow fluid to downshift. The factory service manual has the hydraulic circuits of each gear. You can go through and study this and you'll see. But here's an example of what I'm talking about. This is a valve, this black thing right here. The vehicle speed goes through this, it's called the governor pressure. I'll get to that in a second. Vehicle speed changes the hydraulic pressure, which pushes on this valve. Now when the pressure gets enough, it'll push it down and allow fluid to travel through different passages through here. Because as you can see, it's blocked by this. If you're, say this is the 2-3 valve. Okay, so here's the 2-3 shift valve. Right now, this diagram is for 2nd gear. The governor pressure is the pressure built by the actual speed of the vehicle. So as the speed increases, this governor pressure is going to increase and push this valve down. So when it does, it'll shift to 3rd, and it pushes that valve down and allows this fluid to travel through this passage all the way around different check balls and engage different clutches, and that'll be in 3rd gear. Now say you need some extra power, you'll floor the gas pedal, and the yellow is the throttle valve, which is the one I was showing you up there. So it'll actually redirect the pressure. It'll increase the pressure on the opposite side of the valve, so then it will push it back that way, and you will be back in 2nd gear. I said I'd talk about the governor pressure. This is a governor. Older transmissions have governors. Basically, this is attached to the final drive of the transmission, so this spins at the speed that the wheels spin at. As this spins, these little side flaps here will get pushed away by the centrifugal force of the spinning. And as they get pushed away, it will open up a passage in here which will increase the pressure to the governor assembly, therefore increase the governor pressure, which is that blue line in the last scene. Now this goes into your speed. The speed sensor sort of counts the two teeth going through each second and gives you your speed on the dash. Older transmissions have governor assemblies. Newer transmissions, it does not have a governor assembly. The governor pressure is controlled by a solenoid. The computer will read the speed sensor, and which is pretty much just exactly this, but without this whole gear thing. And according to the speed, it will adjust the pintle width in and out of the solenoid and adjust the pressure from the governor. This is a servo. This is pretty much just a piston, and what will happen is this will be in the case, and when the transmission wants to engage the servo, it will fill the chamber behind this with fluid, and then this shaft will push in, and this particular servo engages that band that I showed you earlier. It'll push on one of the sides and it'll squeeze the drum. In this particular transmission, this is also an accumulator. Accumulators in transmissions are used for if you're driving a standard transmission and you need to engage the clutch smoothly for a smooth shift. You'll let it go smoothly onto the clutch. You won't make it harsh. So this is pretty much the foot in an automatic transmission. If the fluid fills up the clutch packs too quickly, it'll engage them very quickly and very hard. But this will sort of have a reservoir or a cushion for the fluid to not be applied so harshly, and then you will have a smooth shift. So that's pretty much how an automatic transmission works in a nutshell. Thanks for watching.